Find the area of a parallelogram with vertices A, B, C, D, and then answer the question, is it also a rectangle? So if we have two vectors in space, and if they meet at a vertex, then basically you could draw yourself, if these are the two vectors, let's call it U and V. You know, if you repeated this U on the other side, and you repeated the V on the top, that would be a parallelogram. So what we're trying to find out is, if we have a quadrilateral, or actually this is going to be a parallelogram, I'm already going to say that you know it's a parallelogram with these vertices, then let's find the area. Well, one of our geometric properties of the cross product is that the area of this should equal the magnitude of the cross product. So basically it's a way of asking you to find the cross product and then take the magnitude. The second question, is it also a rectangle? Well, if we take these, if this is a rectangle, then we would know that all of these angles are 90 degrees. So the way you check is take the dot product between two of the vectors. If it's 90 degrees, then this is a rectangle. If it's not 90 degrees, then it's not. Now, before I start on this, for something like a parallelogram, we have to make sure that the lines that we're connecting represent adjacent sides of this parallelogram, that we're not, by doing the subtraction to find the vectors, actually finding the opposite sides. So we need to graph the points. And I'm going to graph the points by graphing only the X and Y coordinates, because that'll tell me what I need to know without trying to visualize these things in 3D. So let's see, I need to be able to go, Y is all positive, X's go from, okay. So let me make it something like this. 3, 5. Is about here. That's our A. B is negative 1, 8. Which is about here. C is 1, 3. And D is 5, 0. Okay, so that's our C and that's our D. And so I can see that if I was drawing a shape like this, it would look something like that. Even if it didn't quite look like a parallelogram, the fact is we know that it actually has another coordinate, which is like out of the board or into the board. But that's all right. You know, for my purposes now, all I really need are two vector component form of two vectors. So let me do that. Let me start. The D is 5, 0, 6. And the A is 3, 5, 0. And the C is 1, 3, 11. Okay, I need to find the component form of these vectors. So remember, if given 2 points, an initial point and a terminal point, then I find the component form of the vector by subtracting. 3 minus 5 is negative 2. 5 minus 0 is 5. 0 minus 6 is negative 6. Right? On the other side, between these two. And it's important you get the terminal side, the terminal point minus the initial point. 1 minus 5, negative 4. 3 minus 0, 3. What is my last point? 11 minus 6, 5. Okay, so these are my adjacent vectors that now I can take a cross product. So let me do this. -4, 3, 5. And we're going to cross that with -2, 5, -6. Right, that's a cross product. And we get, right, cover up the first two, and you have 3 times -6 minus 5 times 5. That's -18 minus 25, -43. Okay, cover up the middle two to find the second component, -4 times -6 minus 5 times -2. So that's positive 24 minus -10, which is like positive 24 plus 10, which is 34. But the middle component has an opposite in front of it. So that would be -34. And the last component, cover these up, -4 times 5 minus 3 times -2. That's -20 minus -6, which is -14. Okay, the area of the parallelogram will be the magnitude of that. So the magnitude is the square root of -43 squared minus 34 squared, plus -34 squared plus -14 squared, which is make sure you use parentheses in the calculator. I'm getting 56.57. I'll call it 56.6. All right, that's the area. Okay, next I need to know, is this a rectangle? Well, if it is a rectangle, then if I do the dot product between these two vectors, I should get 0, because that would tell me the angle between is 90 degrees. And that's how we know that something has a 90-degree angle between them. So let me change that to a dot product, and let's just do the math here. -4 times -2 is 8. 3 times 5 is 15. And 5 times -6 is -30. So that's 23 minus 30, which is -7. So is it a rectangle? No, because if it was, the dot product would have been 0, and that would have meant the angle is 90.